Welcome to the Light Ages channel. Here we have a review on a very, very inexpensive multimeter. This cost $21 shipped worldwide, and I thought I would see what you could get for such a low price. I usually don't buy such low-end multimeters for anything other than just throwing in the car, but this one seemed relatively well built from the web page. So let's have a look at this. This is what you get in the box. You get a very extensive instruction manual on a fold-out piece of paper. Not the best, but at least it does tell you how to operate the multimeter. Wouldn't expect much more for the price. You also get the multimeter, of course, and a set of leads. Now the leads, they're okay. They are rated for Cat 2 600 volt and Cat 1 1000 volts. The wire on them, it feels it's okay, I guess, for the price. Very thin, of course not silicone, and they feel rather cheap. No rating on the cables or the wires at all, so I can't vouch for their voltage rating. The probe tips, they're relatively sharp, and but there are no strain reliefs on any parts of the cables here, so these wires are going to break, and I think that's what happened with these leads that I got as I got them out of the box here. I thought I'd try my multimeter, plug it in here, and we'll put it on ohms so we can see what it looks like, and I got nothing. Get no response at all. So okay, maybe there's just something wrong with the ohms range. I thought maybe the multimeter was faulty, so we'll put it on diode select here. Nope, these probes are bad. And so I was beginning to think, well, what could I do to check which wire is bad? And, well, one thing you can do is unplug one. That probe is good. That lead is good. We'll try it the other way around. And nothing. So it's obvious that there is a problem with this lead here. And another way to check this is, I thought, well, okay, this lead might be bad. Let's see where the wire is broken, and of course if the wire is broken down here, they're garbage anyways, not much use to me. But if the wire is broken up somewhere in here, then maybe I could reuse these leads for some kind of, put some clips on here or something, reuse them for something else. So I thought I'd pierce the insulation here and see if I could get a response. There we go. So the leads are good up until this point here. So somewhere inside the probe here, maybe they didn't solder the wires, maybe the assembler was in a hurry and forgot that the wires needed to touch the end of the probe. But anyways, so these probes are not useful. Luckily, the place that I bought this meter from gave me a refund for the amount what it would cost to replace them with the same types of probes, or better probes actually. And so, but luckily I have a set of probes that came from another Uni-T multimeter, exactly the same probe, so we can use these to do our testing. So we won't be cheating. Just as a first test here, how does this respond for continuity? So let's check that. It's already on continuity, so we might as well check this out now. So, wow, that's pretty instant. And you can hear it's a little scratchy, so it's not latched, but what do you expect for a $21 multimeter shipped worldwide? I'm pretty impressed. That's a nice continuity test for such an inexpensive multimeter. Let's have a general look at the rest of the multimeter though while we have it here in this form. You can see the display is easy to see, nice big numerals. Annunciators here for different functions. The range switch is easy to move. Has a nice feel to it. It's possible to get it stuck between settings, but you really have to try. So I would give that dial a pretty good rating. It works very well, feels good, and it goes where it's supposed to. The input jacks, of course, the input jacks have the same thing that Uni-T does on all of their multimeters. They don't bother color coding the input jacks, so you have to be careful. You look at what you're doing. Yes, they're labeled. This multimeter has a CAT rating of Cat 2 1000, oh, Cat 2 600 volts, sorry, which is, I guess that's what I would use this for. I would definitely not use it on Cat 3, and I'm not sure I would use this up to 600 volts regularly, but I guess if you're just working on the inside of electronics and testing out the transformers, this meter is probably going to be safe enough. The input jacks for the current measurements, they are fused. They are only rated at 250 volts, so this really isn't a Cat 2 1000 volt. You can't do that anymore. You have to have fuses with the same ratings under the current specifications for Cat ratings. We have a select button here for selecting different functions depending on what function you are in, and selecting alternative functions or selecting ranges. A simple, silly hold button, which really is useless. I would have preferred to see that button omitted and save some cost. The overall construction of the multimeter is very good. You can see here it's solid. It's very difficult to make it move at all. We have a nice wide standing tilting bail here with a wide base on it, and it looks like it would be useful because it's such a wide base, but the problem is that the combination of the way things are angled here, when you try to move the dial here, the thing just moves around. So yes, it stands up and it's nice and stable and you can push buttons no problem, but when you want to change the dial, you really have to push down almost to break the stand to keep it from spinning around. So yeah, that's one of the problems with this. The other problem is that it has just these hard plastic points on the back, so when you try to use it on a table, again, it just moves around unless you put a lot of force down to try to keep it still. I guess that's an acceptable compromise on such an inexpensive multimeter. So overall, it has a nice display. It has good construction, and I would have to give it a pass on just the overall. Well, I'm actually impressed with the overall appearance and the construction of it from the outside. So let's take it apart and see how it looks inside. So let me get my screwdriver here. We will turn this off. This has a very nice feature. The battery compartment has one screw here. Unfortunately, none of the screws are into metal receivers. They all are into plastic holes, so they're just self-tappers. But the battery compartment, I'm really quite pleased with this for the money. The battery compartment has this nice holder that holds the battery in place as you take it out. Has these contacts for the batteries soldered directly onto the circuit board. That's a nice feature for an inexpensive meter. We have two more screws here holding it together, and another one here, and then it just comes apart by pulling on it, and you can see that it has some really nice high walls here that go into a very deep groove, so it's got a very good solid construction. That's probably what contributes to some of its solid feel. The plastics, that's typical plastics, a little bit better than some of the other really cheap multimeters I've felt. This specifically says ABS here. You can see the piezo speaker on the back here, which is a nice way to do it. The piezo speaker connects to the circuit board using these two springs here, and you can see again the battery connectors soldered directly to the circuit board. We have a few little cheap trim pots here, 4 of them at least. And then we have our input jacks here, the split tube type, relatively cheap, but they're not soldered directly to the circuit board, so the solder for the connection shouldn't break too easily. You can see the cheap 2 little fuses here. This one's for the milliamp range, this one's for the amp range, rated for 250 volts, so that's why I would keep this away from any high energy circuits. We have a PTC here. There's no MOV, a couple of resistors going off to different things. A diode bridge to protect the milliamp range and the amp range for overvoltage. And you can see it's got very few parts here. It's generally well constructed. These switches here have a little bit of flux residue left over, but the soldering is generally pretty good. Not too much on this side of the board. The circuit board is held in here with two little self-tapping screws again. And the circuit board is also held into place by two snaps, basically on each side of the circuit board here. So we have to spread the case apart a little bit to get them to come free. And then once we do that, the whole circuit board lifts out and leaves. Wow, that's in there very well, very solid. Okay, so I had to push up on the selector switch a bit here. So you can see inside the case here the guides for the input jacks, our push buttons here, a nice solid acrylic window. I guess it's acrylic. I shouldn't say that it is, but and the selector switch just is held in there. There's a little bit of grease and these two balls on springs here. That actually works fairly well. I'm impressed the way that selector switch feels. And we'll put that back and we'll put that aside. On the other side of the circuit board here, really not that much to look at. We have what appears to be gold, or it appears to be, might have some gold or a nickel alloy coating over the selector switch contacts. You can see a gap here routed out on the circuit board with a corresponding divider here to prevent the high amperage range from flashing over should the fuse blow. We have our two push buttons here. They're just momentary. And then the LCD is, it looks like it's glued down. We have a couple little glue spots here. And yeah, there's a couple of pins here. And underneath I can see there's a chip-on board just with some epoxy over top of it and some other random components passes under there. There's not really much to this multimeter. Very thin board, but it seems to be relatively well constructed. I'm impressed for the price, definitely. Now that I have this back together, let's see how it performs. So let's do some testing on it. Let's bring in my voltage standards DMM check. And let's do some basic checks on it here. So let's put it to volts. Plug in my leads here. And this should read exactly 5 volts. 4.99. That's pretty close. You can't complain with that. That's well within spec, even if you just count the significant digits out it can be. Let's see, what does it say here again? Says 3 significant digits, 0.8%. And no, actually that's 0.1 significant digit, 0.8% for that voltage range. But you will notice here, as it's sitting here, that this auto ranges all the way from millivolts up to volts without having to make any changes to it. And you can see the update rate is pretty good here on volts. I don't think I saw any overshoot there. Ah, yeah, there's some overshoot. Oh well, what do you expect for $21? But it gets there fairly quickly, so that's pretty good. Let's do a check on the ohms range here. Let's see what it measures for ohms. This should read 999.7 ohms. It's a little slow getting there, but it does get there. So a little bit slower on the auto ranging and the update rates on ohms, but it does a reasonable job for the price. This should read 999.7. It reads 998 ohms, so that's well within spec. 9,999. That's well within spec. And 99,999, so 99.9 kiloohms. Perfect. That works very well there. Let's check out the milliamp range. Of course, on an inexpensive meter like this, you can't expect it to have input jack alert or anything like that to warn you if you've put your leads in the wrong position. This should read exactly we're on the microamp range here, so this should read exactly 1000 microamps. Perfect. And on milliamps, it should read 1 milliamp, and yeah, that's well within spec also, just fluttering on one significant digit. So let's check to see how this does on doing some other component tests. Let's check to see how it does working on diodes. But before we do that, let's see what voltage it outputs. So you can see here that it only puts out around 1.49 volts. That's not going to do anything for an LED, but let's try it anyways. Here you can see I have some LEDs on a circuit board. Sorry, I don't have any free LEDs to test with here, but just so you can see that these LEDs actually do work. Let's see. Oh, I have to put this on diode to test, of course, first. Okay, so we have red LEDs and a white LED working. You can see the Bryman doesn't do a test voltage, or it doesn't give you a voltage indication for the voltage drop on the white LED, and we have 1.8 on the red LEDs. So let's do the same thing with the Uni-T. Get my leads into position here, and nothing. It just flashes, but it doesn't give you any indication what it's doing. I'm shorting out the one side, going to the other side. Nothing. So it won't even start up an LED of any type, even the lowest voltage type. Will it measure a regular diode without any problems? I'm going to assume it can. It has to do something on a diode test. Yeah, okay, that's the right value for that diode. Let's turn it around, make sure it's not fooling around. Okay, that works fine. Let's test it on some capacitors. So let's select our capacitance range here on the Bryman so we can do a comparison. First one will be this capacitor here. Let's delta out our leads here. And this is reading 0.05 nanofarads, so around 50 picofarads. That's one thing that I'm surprised with this multimeter, is that it goes down to picofarads, but it has an extremely high residual capacitance built in. So let's let it settle down for a second to roll that out again. So this is reading a little high on the low end of the capacitance range, so it's not that great. The specifications say here for capacitance test down at that range for reference only, so I guess we can't blame it for not measuring correctly down at that range. 4 nanofarad range, so let's go up to a bigger capacitor then. So it tells you that you at least have a capacitance and within an order of magnitude what it might be. Let's re-zero out the Bryman here. This capacitor here, 6.81 nanofarads. So, of course, this is still down. Oh no, this will be on the next range. That's pretty good. That's not bad for a cheap little multimeter with my hands in the way here, making a mess of the measurement. Yeah, so it's a little out of spec, I would say, but it still says 4% down at that range. Let's re-zero the leads again here. That's an extremely high residual capacitance. I'm really surprised. So yeah, that's reading a little high, but that's down at the bottom range of what this multimeter is meant to measure. Let's measure another bigger capacitor here. And of course, as I move the leads around, it changes its residual capacitance. This one says Okay, so what's going on here? I just didn't have a good connection. This should be a 22,000 picofarad, so 22 nanofarad. That's pretty close. How does that compare to the Bryman? That's very close on that range. Let's test a 2.2 microfarad capacitor here, nominal. 2.160. Let's compare that to the Uni-T. And yes, I know I'm not keeping my polarity the same. Well, that's pretty close too, so you really can't complain about the accuracy of this for doing some rough capacitor measurements. How does it do on measuring a 1000 microfarad capacitor? So let's get this connected up here. And it goes to sleep, so we have to wait. It takes a few seconds for this to do a reading. Doesn't tell you what's going on. It just sits there blind until you get a reading. And it says overload. I forgot to check. Yes, it only goes up to 100 microfarads on the measurement. So if you want to measure high value capacitors, you can forget this multimeter, but it does measure mid-range capacitors fairly well. So let's see how this thing performs with changing voltages. And we have it connected in parallel with my Bryman here. This is reading in the millivolt scale. This one's still on the volts, but because it's a 50,000 count as opposed to a 4,000 count, we get the same number of digits, significant digits on the measurement. And you can see it updates fairly quickly. It auto-ranged very quickly. You saw how it jumped here from millivolts to volts very quickly. And the update rate, I would say, is 3 times a second. It's better than 2 for sure. And it seems to be tracking the Uni-T or the Bryman fairly well. Let's ramp up the voltage quickly here. Yep. It auto ranges very quickly. That would, but it also overshoots, so a little trade-off there. But for a cheap little multimeter, the update rate is very good. Let's see how it performs with current measurement. Okay, I have the meters connected in series here, so we're going through one current shunt into the other current shunt and back to the power supply. So let's adjust the, well, you can see they're agreeing fairly well down here on the high amp range, down at the bottom end. And as I crank this up, yeah, it's agreeing fairly closely. Let's crank it up a lot more. Yeah, very close. Let's get it up to closer to an amp. And it's a little bit out, but it's still acceptable for its specifications. And we'll take this up to 3 amp. We won't go any further. Approximately 3 amp. And yeah, it agrees within its specifications to what the Bryman measures. So that's a good high current measurement accuracy also. Now we will compare the two multimeters on how they respond to AC voltage. Now you can see the I have it set to approximately 100 millivolts here on my my function generator actually. This is auto ranging down. It's not auto ranging down. That's the other thing I needed to show you. In the voltage mode or volts DC mode, it auto ranges all the way from millivolts up to 1000 volts without having to change anything. When you're in AC volts, it stays in the 4 volt range. If you want to get it into the millivolt range, you have to manually range it all the way to the top and wrap around to the bottom, and now we're into millivolts. That's the one strange quirk with this. Well, that's not the only strange quirk. There's a couple of other ones, and I will show you those too. But anyways, here we are, 101 millivolts thereabouts compared to the Bryman. That's fairly close. Let's move it up a little bit. Let's get it up to, oops, overranged that one too quickly. Up at the upper range of the millivolts, they're agreeing fairly closely. And we'll put this back to auto now. And we'll ramp it up to over a volt. Agreeing, no problem. Let's take it up higher. Updates very fast. Of course, this is not a true RMS. and all the way to the top range of my function generator's output. And yes, they agree within spec, definitely. So the AC voltage on this works very well. We also should check the frequency. So let's switch this over to frequency, switch this over to frequency. And I've got it set to approximately 50 Hertz. Let's take the voltage down to a more middle range here. And let's take it up to 100 Hertz, no problem. 200 Hertz, no problem. Let's see how they measure at 200 Hertz on the voltage. That still agrees. Let's take it up to 2 kilohertz. That's still holding on for its voltage accuracy at 2 kilohertz. 10 kilohertz, okay, we start to drop off here. The specification says here for the AC voltage 40 to 400 Hertz, so it beats its specifications for the measurement. If we take this back down to 4 kilohertz, you can see it agrees, so it beats its specifications for AC voltage accuracy, no problem. Anyways, let's go back to measuring frequency, and no problem there. We're up to 3 kilohertz. Let's take it up to 10 kilohertz, 20 kilohertz, no problem. 200 kilohertz, there it agrees. 2 megahertz. So up to the upper range of my function generator, we can read no problem up to 2 megahertz, and then beyond I can go a little bit beyond. What's the lowest it can go to? So let's set this to a nominal 100 thereabouts. And let's go back down to 100 Hertz, 10 Hertz, 1 Hertz. Okay. Oh, it does read. It actually reads better than the Bryman down at this range, so that's a good pass for that one. I'm happy with the frequency response and the frequency measuring range of that multimeter. Let's go back to 100 Hertz. This one's reading duty cycle on sine wave. This one doesn't want to read duty cycle on sine wave at this setting, so let's put it on square wave. And now they match. Okay, so now we can play with the duty cycle. So we will turn this up in one direction, 74.6. Okay, so there's nothing to complain about. It's duty cycle accuracy. And we'll invert the duty cycle, 6.9. Yeah, this is reading fine on frequency and on duty cycle. So you can trust this one to give you fast, easy readings without having to play with settings too much. So here we are looking at how it performs on the current measurement ranges on AC current. And I'm down at the bottom here of the capabilities of my function generator here, and you can see it agrees very closely, and 40.5 microamps for both of them approximately. Let's crank it up and get it up higher. Yep, agrees pretty good. I put it past its auto range here, so near the top of its counts. It's agreeing well within specifications again. And let's take it up higher and higher. Let's let it settle there for a moment. So 1.243 milliamps, or 1,243 microamps. It's agreeing fairly closely. While we're on the microamp scale here, let's take it up as far as I can go. And it's agreeing all the way up, well within specification. Let's switch them both over to milliamp. See how they compare. I'll have to put this on DC, or AC, sorry. And they agree at that range. Let's take it down. Yeah, it's well within specification, very close to what the Bryman thinks it should be. So that's pretty impressive performance. Now, if you are looking to buy this multimeter because you don't have a lot of money, you might be concerned about battery consumption too. How often are you going to need to replace this expensive 9-volt battery? Well, as you can see, even on the DC voltage scale, it's drawing 1 milliamp. When we switch it to AC, it draws approximately 1.8 milliamps. Put it on ohms, the same, well, it drops down to 1 milliamp. Put it on continuity or diode, approximately 1 milliamp. Capacitance, less than a milliamp. Frequency measurement, less than a milliamp. No change on duty cycle. On current measurement, it goes up to 1.8 again. And if we select AC, it doesn't change. So the power consumption on this multimeter is somewhere between 1 and 1.8 milliamps. So this should give you at least 100 hours on a 9-volt battery, maybe up to even 200 hours. How does it perform on extracting as much voltage as it can out of the 9-volt battery, or much power? Let's turn the voltage down, see when the battery warning comes on. Wow, that's going a long ways down before the battery warning comes on at all. There we go. Battery warning comes on at 3.8 volts. So this is very frugal on batteries. This is going to last a long time on batteries before you have any problems with it. So this is a very good, inexpensive multimeter. Very good power consumption on the battery. Very well built. All the functions that you might want in a multimeter. There are other models of this range in the 136 range. There is an A model which drops a couple of functions. I believe it drops the capacitance and the diode test or something like that. It's not worth looking at. The C model costs a little bit more. It comes with a temperature probe and temperature measurement, but it does drop the capacitance mode. Then there's also the D model, which drops the capacitance mode but has a non-contact voltage detector, so you can detect live wires. But this is not the kind of meter you'd be wanting to take around to do house wiring or plug into the sockets, those kinds of things. So this is probably the best buy, the most versatile multimeter out of the bunch for a multimeter on the bench. Now, some people say that, and I agree, that you should have more than one multimeter. So you have the option of buying this one and then buying the one with the C model with the temperature measurement, and then you have two multimeters that you can do all kinds of electronics work on your bench for less than $45. 2 meters, not true RMS, few little quirks, but very useful multimeters for the price, and I would recommend them.